Before starting the next lesson, try the warm-up. Do you know how to calculate the amount of force on an object given its mass and acceleration? This is a physics question. Maybe you've taken physics before and you know the answer off the top of your head. Maybe you need to do a little research. Either way, pause the video and see if you can find an answer to this. All right, so you might have found force equals mass times acceleration. That's correct. If you want to get more specific to gravity, the force of gravity is equal to the mass of the object multiplied by the acceleration due to gravity, which is 9.8 newtons per kilogram. Okay, so multiply your mass in kilograms times 9.8, and you'll get the force due to gravity. Now, the reason I bring this up is because it's going to come in handy later when we're looking at applications of vectors. So you've looked at geometric and algebraic representations of vectors. We're going to use those ideas to solve actual real-world type problems. Example 1. A 5 kilogram sign is suspended from 2 wires. Calculate the amount of tension in each wire. Okay, so tension is a force, it's a vector. Okay, so we've got this sign, it's 5 kilograms. We've got a force pulling down, the force of gravity pulling down, and the tension in the wires are going in the opposite direction to hold the sign up. So I'm going to label the tension in this wire as T1, the tension in this wire as T2, and the force of gravity I'm going to calculate as 49 newtons. So this is just doing what I did in the warm-up. 5 times 9.8 gets me the number of newtons of force. Okay, just so you are aware, newtons is the unit for forces. Now let's do a little bit of thinking. Is the sign moving up or down? Left or right? No, it's hanging there. It's staying still. So that means all the forces have to balance out. So if gravity's pulling down, the upward forces are going to balance that out. Okay, so another way you could think of it as is if we add all these vectors together, the result is going to be 0. It's not moving anywhere. So if I draw that graphically or with the picture here, T1 plus T2 plus the force of gravity starts and finishes in the same spot on a graph. Okay, so we're not moving. Okay, the resultant vector is 0. So I'm going to use this diagram to figure this out. I'm going to add some angles in here. Okay, so if I look at T2, got a 45-degree angle down from the horizontal. Force of gravity, that hangs straight down, perpendicular to the horizontal. So I know perfectly horizontal and perfectly vertical meet at a 90-degree angle. So if this is 45 in here, the rest is going to be 45 as well. Okay, so there's a 45-degree angle in here. Okay, now T1 hangs at a 60-degree angle from the horizontal. Okay, now if I did that Z pattern, this would be 60-degree angle down here. Okay, so over here, here's T1. That's the 60-degree angle down there. That's what I just said. There's a Z pattern. So this angle in here is 60 degrees. Okay, now force of gravity hangs perpendicular to the horizontal. So if this is 60, the total's 90. That means I have a 30-degree angle in here. Now, if this is 45 degrees and this is 30 degrees, the third angle must be 105 degrees because all 3 angles inside a triangle have to add up to 180. Now, if I know the force of gravity, if I know the magnitude is 49 newtons, and I know all the angles inside my triangle, then I can figure out the magnitude of the tension in the wires using trigonometry. Now, I'm going to use the sine law here because I know an angle and its opposite side. So let's set it up to find the tension in the first wire, T1. 49 over sine 105 equals the magnitude of the tension in the first wire divided by sine 45, because those match up opposites. Cross multiply and divide. So I get 49 sine 45 divided by sine 105, and that ends up being around 35.9 newtons. Now I'm going to do a similar thing to find the tension in the second wire, T2. So 49 over sine 105 equals T2 over sine 30, because those are opposites. Rearrange 49 times sine 30 divided by sine 105. I get 25.4 newtons for the magnitude of T2. Now, since the question is just saying calculate the amount of tension, that's just referring to the magnitude. So if I have the magnitude of T1 and the magnitude of T2, that's all I'm asked to find. So here we are, we're done. Here's my second example. Anne and Bob are pulling a sled as shown. So here's the sled. They're pulling the sled. Anne is pulling with 70 newtons of force, so she's pulling up at a 30-degree angle, and Bob is pulling down at a 50-degree angle the other way. Okay, so what force should Bob exert? So what magnitude of force should he exert going this way to keep the sled moving straight, so along the dotted line here? Okay, so the sled is moving straight. Anne's pulling up in this direction. Bob is pulling down in this direction. We want to know what amount of force he should be pulling with. And I'm going to solve this algebraically. First, I'm just going to label this vector A for the direction Anne is pulling the sled. Vector B is the direction that Bob is pulling the sled. Okay, so vector A, the x component is 70 cos 30 degrees I hat, and the y component is 70 sine 30 j hat. So I've got x and y, right and up, and then for Bob, he's going right and down. So x component is x cos 50 I hat, and y is down, so it's minus x sine 50 j hat. Okay, now, the sled is going to move straight. So up and down is 0 for my resultant vector. To solve this problem, I don't really need to know what the x component of my resultant variable is. I don't know how much force they're pulling it in the straight line with overall, and it doesn't really matter because I'm just going to focus on this part right here to solve my problem. Because all I want to do is find the magnitude of x. Okay? And if I look down here, I already have an equation. Because I know when I add these y components together, I'm going to end up with 0. So 70 sine 30 minus x sine 50 equals 0. So I start with that equation, and I can just solve. Okay, so I move this term over. So now 70 sine 30 equals x sine 50. Divide both sides by sine 50 to get x by itself. And when I do that, it's about 45.7 newtons. So I can say, therefore, Bob should pull with 45.7 newtons of force. Example 3, determine the resulting force. So here I have an object with a bunch of forces pulling in different directions. Up, down, left, and right. I'm just going to label them vector A, vector B, vector C, vector D, and vector E. Okay, if I want to determine the resulting force, well, I could do this geometrically. I could draw it out, put it on a grid or something and draw it out. I'm going to choose to do this algebraically. So I start by setting up my table A, B, C, D, E in the x and y components. So for A, there's no left or right movement, so x is 0, but there's vertical up 25, so plus 25 j hat. And likewise with the other ones. This one goes right, so that's positive 12 I hat, and not up or down, so 0 j hat. Okay, you can see the idea. If I'm going down, I'm going in the negative y direction. If I'm going left, I'm going in the negative x direction. Add up all my x components, add up all my y components, and I get the resultant is 8 units in the x direction and 11 units in the negative y direction. So write 8 down 11. Okay, so I can use Pythagorean theorem to find the magnitude of my vector. Okay, so x coordinate, y coordinate, add those up squared, take the square root, it's about 13.6 newtons. Okay, now we've got to get direction. We have magnitude, now we need direction. Well, I know I'm going to the right and down, or east and then south, but what angle? So I need to figure that out next. This is where I'd use the tangent. So tan is opposite over adjacent, or the y over the x, 11 over 8. Take the inverse tan to get the angle. It's about 54 degrees. So I can say R is 13.6 newtons, east, 54 degrees south. And I know that because I'm going in the positive x direction, or the east direction, and the negative y direction, or the south direction. And here's my last example. A pilot set a course of 500 kilometers per hour north, 30 degrees east. The wind is pushing the plane, so it is traveling 400 kilometers per hour north, 60 degrees east. What is the velocity of the wind? Okay, so the picture here is the pilot is pointing the plane in a certain direction and traveling at a certain speed, but after the wind is pushing the plane, the resultant velocity is 400 kilometers per hour in a different direction. So we need to find the velocity of the wind here. Now, just so we can kind of visualize what's happening, I'm going to draw the first one. So the pilot set a course 500 kilometers per hour, north, 30 degrees east. So he's going north and then 30 degrees towards the east. Okay, so that's what I have in blue. Now, the wind is pushing the plane. Okay, so it is traveling. Okay, this is the resultant. So the original velocity plus the wind comes up with 400 kilometers per hour north, 60 degrees east. Okay, so north, 60 degrees east. It's getting pushed farther east. So that's what I have in green on the diagram. Now I've shown the wind in red. So the wind is going to be blowing this way to push the plane so that the resultant is what's in green. Okay, so the original course set plus the wind gives us the resultant vector. Okay, so we have enough information. We could solve this geometrically. You could draw the diagram, figure out the angles, and use trigonometry to find the magnitude and direction of the wind. I'm going to do it algebraically because I think overall it's a little bit easier. But if you try this geometrically, you should get the same answer. Now, I'm going to just label P, vector P is the plane, the course set, the pilot set the course. That's the original course set, P for plane, and then R is the resultant. So P plus W equals R. Now, of course, I know what P is and I know what R is. I want to find W, so I'm going to rearrange this equation to solve for W. So W equals R minus P. Okay, so I have R minus P. Here's R, here's minus P. I can get those together and figure out what W is in the X and Y components. Okay, so I've got the magnitude of R is 400 because it's 400 kilometers per hour. The magnitude of P is 500 because it's 500 kilometers per hour. And I've got the angles 30 and 60. Now that seems a little odd because it should be 60 and then 30, not 30 and then 60. So what's going on here? Well, if you'll recall from a previous lesson, when I look at the angle to using the X and Y components, I'm looking at that right triangle that gets made. So if I'm thinking about R, okay, so there's R. Now if I break it into a right triangle, well, I know in the question that this angle's 60 degrees out here, but I need this angle in here, which is 30 degrees, because here to here is 90 degrees, so the remainder is 30 degrees in here. So that's why I have 30 degrees up here. And similar with P, for the blue triangle. Well, it's 30 degrees to here, but I'm looking at this right triangle right here, so the angle in this spot is 60 degrees. So that's why I have a 60 degree in here. Okay, so I didn't get those mixed up. I didn't make a mistake here. I'm just showing you got to think in terms of the right triangle that it's making with the horizontal. Okay, so let's add these together. 400 cos 30 minus 500 cos 60. That's 96.4 I hat. Now the y coordinate, 400 sine 30 minus 500 sine 60. It's minus 233.0 if I round, j hat. Okay, so for the wind, I have the x component and the y component. So it looks like the wind is going in the east direction, the positive x direction, and then in the negative y direction, which is south. So east, then south. Now we just need to find the magnitude and the angle for the direction. So recall I used Pythagorean theorem with the x and the y components to find the magnitude of the vector. So the wind is traveling at 252.2 kilometers per hour in an east and then a south direction, but I need to know the angle that it is south to have a more precise direction. So the tangent of the angle is opposite over adjacent, the y component over the x component. Take the inverse tan to get the angle, which is about 68 degrees. So I can say the wind velocity is 252.2 kilometers per hour, east, 68 degrees south. And I know it goes east, then south because of the x and y components of my vector. It's in the positive x, which is east, negative y, which is south. Okay, so there's some applications of vectors. You can solve vector problems geometrically or algebraically. Either way is fine. You should arrive at the same answer. So now just try some practice problems, and if you run into trouble, reach out and I'll do my best to help.